Welcome to an introduction to R for geospatial data. This workshop will teach the basics of R and provide a foundation for using other geospatial data in R, such as raster and vector data. This first episode is an introduction to R in RStudio and will answer questions such as how to find your way around RStudio, how to interact with R, and how to install packages. Before starting this episode, you'll need to make sure you install the latest version of R and the latest version of RStudio. We'll also be using some packages throughout this workshop, but we'll talk more about how to install them in this first episode. First, let's take a look at RStudio. RStudio is what's called an interactive developer environment, so it allows you to create scripts and work with the R programming language and provide some tools for making that a little bit easier. First, let's look at the basic layout of RStudio. When you first open RStudio, you'll notice there are several panes showing up in the window. One is the console pane, which takes up the whole left-hand side when we first open RStudio, and the other is what's called the environment pane and the files pane, which you can see on the right-hand side of RStudio. These panes are tools that'll help us to use R more easily as we work within RStudio. When we first open RStudio, we see only these 3 panes. However, it's much more common to actually see 4 panes in RStudio. The fourth being the source pane, which actually shows a script. Usually that is on the left-hand side above the console pane. In order to see this script pane, we can open a new script. To do so, we'll click File, New File, and then choose RScript. And you'll notice when I choose RScript, it opens the source pane in the upper left-hand corner of RStudio. In doing so, we now have an untitled script with no code in it. We'll dig more into scripts in the second episode of this lesson. For now, let's work with the console, and I'll go ahead and close this script by clicking the X next to it. One of the things we can use R for is as a calculator. In the console window here, you'll notice above there's some information printed about the version of R and a welcome message with some information. And then there's this greater than sign with the blinking cursor. This is the console where we can enter different commands for R. One of the ways we can use R is as a calculator. So we can type things such as 1 plus 100. And then when we press enter here in the console, it will actually run the calculation and print back the result for us. Note, I added the spaces before and after the plus sign. They're not strictly required for R, however, they make it much easier for users like us to actually be able to read the code a little bit better. You'll notice next to the resulting calculation, there's the number 1. This we'll get more into later as we learn more about different data types in R. Let's see what happens if we start a calculation, 1 plus, for example, and don't finish it and press enter. So here, I started the calculation with 1 plus. You'll note I did not use the space this time. But the problem is I didn't put the rest of the calculation. I put nothing on the other side of the plus. And so now the console, instead of having a greater than sign, has a plus sign there. That indicates that it's waiting for more input. One option I could do now is complete the calculation. I could type it here. However, sometimes when you get stuck in the middle of a command like this, it's helpful to be able to escape and start fresh. And so in R, the option to do that is actually to press the escape key. And so I'll press escape and I'll get my console back and it's reset and it did not finish the calculation. We can do other calculations that are more complex, such as 3 plus 5 space this star that's an asterisk. It stands for multiplication here. And we can run that calculation as well. We can also change the order of operations using parentheses, similar to what we would do if we were writing out a math problem, times 2. Some other operations you may do are exponents, division, subtraction. Other calculations are built into R. Oftentimes, if we're doing a calculation that results in a really large number or a really small number, R will default to showing us the scientific notation instead of the full notation of that number. And so let's try that out by typing 2 divided by 10,000. And I'll go ahead and press enter. And you'll note that it gave me back the answer in scientific notation. I can also type something in scientific notation and see the result. So if I type 5e to the 3 and press enter, it will expand that notation and show me that that is 5,000. In addition to calculating, we can also compare items to one another. So if, for example, we wanted to find out if 1 is equal to 1. So 2 sides of the equation here, we could have more complex equations on either side, but if we want to assess the equality of the left side of the equation to the right side of the equation, we can use this double equal sign. And so this double equal sign stands for asking the question of, is the left side equal to the right side? And when we press enter to evaluate that statement, it'll tell us true if they are equal, and false if they are not equal. Those are logical values that R will output depending on the comparison you're making here. We can also evaluate using greater than or less than. So we could say 1 is less than 2. That also gives us a true value, a true output. In addition to calculations and comparisons to values, where R and most programming languages really become very valuable to us as researchers is when we start to take advantage of what's called, in math we call variables, in R we called objects. And so in R, we can create objects to store information for us, and that ability to abstract values into containers that are objects lets us reuse them, replace those with different values, and run the same operations on them, and is one of the most valuable things about programming itself. Let's take a look to make this a little bit more concrete. Let's assign a value to the character x. So we can say we want x, and then in R we use what's called the assignment operator, which is the less than sign and a minus sign. The shortcut for this is also Option or Alt minus sign, depending on if you're on a Mac or a Windows machine respectively. So I have 2, I only need 1, so I'll go back and erase the second one. So I'm going to assign something to this object x in R. And so on this right side of the assignment operator, I'll put a calculation. So I'll say divide 1 by 40. And I'll go ahead and press enter to run that line of code. And here you can see that once I've run the code, up in my environment pane here, now I have a new object in my environment. This object is called x, and the value of it is 0.025, the results of my calculation that I did. What happened when I ran this calculation is R ran the calculation and then assigned the result into the object x. You may notice that contrary to my previous calculations, it didn't print the result of the calculation. Instead, it only assigned it to that object in R. And so if I want to see what that object is, maybe I have a lot of objects in my environment pane, so I can't see them all. I can type X, and it will print out the result of the X object, print out what is stored in the X object. Alternatively, I can also print and assign at the same time if I add parentheses around my assignment. So let's assign something to an object called Y. We'll use our assignment operator. This time we'll multiply X by 50. So in this expression, I'm also using an object in my calculation. So I'm going to take whatever the current value of X is and multiply it by 50 and then assign that to the object Y. And at the same time, since I've surrounded it with parentheses, I should also see the resulting calculation print on the line below. Let's go ahead and run this by pressing enter or return. You can see the result of the calculation is 1.25. It printed here in the console after I ran the line of code, and it also assigned it to that object Y, and I can see that in my environment pane. Now I have 2 objects an X and a Y with two different values here. Also note that objects can be reassigned to different values. So if I want to reassign the value of X, I can type X assignment arrow 100. This time I won't have it print, but I will change the X value, and I'll press enter. And notice it did not print X out because I did not surround it in parentheses this time. However, it did change the value of X. So if we look here in the environment pane, we can see that the value of X is now 100. Let's do a little bit of a challenge to see more about how objects work. Try out this challenge to practice more with variables. Assign mass and age and reassign them using calculations and see how they change. Before running the second two lines, guess what you think the resulting change in the value of mass and age will be. When you're ready to continue, unpause the video and we'll go over the answer together. Let's take a look at how age and mass change as we assign them. First, we'll assign mass, assignment arrow, to 47.5. If we go ahead and press enter, we see mass comes into our environment and has the value of 47.5. Next, let's assign age. Age assignment arrow 122. We can see that age is read into our environment and has a value of 122. Now let's modify the value of mass. So let's take mass, and we're going to use the assignment, so we'll reassign to it. And we're going to take the value of mass and multiply it by 2.3. This takes the current value of mass, multiplies it by 2.3, and overwrites it, saving it to the value of mass. So our new value of mass should be 109.25. When we run this line, we can see it overwrote the original mass value of 47.5, and now mass is equal to 109.25. Let's try this with age. So we're going to take age and the assignment arrow, and we're going to take the original value of age, subtract 20, and we'll go ahead and press enter. And we'll notice that now the value of age subtracted by 20 and now is 102. To continue on this challenge, let's try a comparison between mass and age. Is mass larger than age? How would you find out using R? Unpause the video when you're ready to continue on with the answer to challenge 2. Let's find the answer to this challenge together. For this question, we're asking, is mass larger than age? And so we can do one of those comparisons that we did before. We'll say mass greater than age. And in this case, we're asking the question of R, is mass greater than age? We should get true or false, whether that's true or not. And the answer is true. Mass is larger than the age because the value of mass is 109 and the value of age is 102. In addition to the many calculations and statistical functions that are built into R, which is called base R, you can use many other functions and data types that are developed by other individuals. This is using packages in R. A very popular package in R is the tidyverse, which is actually a collection of packages that are useful for working with data. In our work, we'll be using specifically the dplyr package, dplyr, from the tidyverse, and the ggplot package. In order to install those, we'll use the function in R to install packages. So let's install dplyr. We'll type install.packages, and then open parentheses, because this is a function of R. And then in quotation marks, we'll tell it we want to install dplyr, also called dplyr. I'll go ahead and press enter and run this. A message will print out as it installs the package, And finally, it'll tell us that it downloaded the binary packages. That's an indication that it has finished the installation. To check that this package has been installed, there are a couple options. One is we can take a look in the Packages pane in R. So if we change the File pane here to the Packages tab, we can scroll or search until we find dplyr and see that dplyr is installed. We can also, in the console, type library dplyr and press enter. If we saw an error, we would know that this dplyr package is not installed. What we're actually seeing here is a warning that dplyr gives us about how it relates to some of the other functions that are in R. It's telling us that there are some functions in dplyr that match other functions names that are in stats or base R. And by loading this package, we're actually giving priority to the versions that are in dplyr. So this is actually a very helpful message. Typically, when you load most libraries, it won't give you any message. But for dplyr, it gives us this helpful message about the different functions that it uses that are also in the stats and base R packages. Later in this lesson, we'll be using ggplot2, and you'll need to have it installed. For this next challenge, install ggplot2 and check that it is installed. When you're ready to see the solution to this challenge, unpause the video. Let's go through the answer to this challenge together and install ggplot2. I'll type install.packages, open parentheses, quotation marks, ggplot2. And I'll press enter. And here it's installing ggplot2. I can check that ggplot2 is installed by searching in the packages pane, ggplot2, and I can see that it's installed here. I could also type library ggplot2 to load that library into my environment. And you'll notice that this one did not print any messages. It did load the package because it existed. If it hadn't existed, it would have given me an error. Let's see what happens if I try library ggplot3, which is not a package that exists and I have installed. I press enter. I see error in library ggplot3. There is no package called ggplot3. So this is what happens when you try to load a package that is not installed. You may also note that when I loaded the package using library ggplot2, it put a check mark next to the name in the packages pane here. The check mark indicates all of the packages that are currently loaded into my R environment. If I hit X, you can scroll through and see things such as base, datasets, dplyr, and ggplot, graphics, gr devices are already preloaded into my environment, and others. This concludes the episode An Introduction to R in RStudio of the Introduction to R for Geospatial Data lesson. Please see the next episode for more fundamentals for working with R.